Machine learning uses statistical techniques to give computers the ability to learn without being programmed. Email is automatically filtered for spam. Navigation maps calculate the fastest routes. Self-driving cars transport people to work. While the rise of super-intelligent machines has been extraordinary, imagine the possibilities if we could teach machines how to predict emotion. At MIT, Professor Dina Katabi and PhD student Mingmin Zhao have opened up this realm of possibility with the development of EQ radio, a new emotion recognition technology. Although wireless signals can be used to measure a person's breathing and average heart rate, that in and of itself is not enough to predict a person's emotion. Katabi and Zhao developed EQ radio to solve this problem.
So the way it works, it has three parts. So the first part, it transmits a very low power wireless signal and it captures the reflection of that wireless signal of the human body. So like that signal travels, for example, and reflects, because our bodies are full of water, it reflects off the human body. But those reflections are very, very small, minute signals. So the radio has to be very sensitive to be able to capture them. Then the second part, now that we got this minute signal, how do we learn from it someone's breathing and heartbeats? And one of the challenges that we face is that it's not enough to get heart rate. We needed to get beat by beat, the length of every single beat.
An ECG monitor has very clear peaks, allowing for easy segmentation of the heartbeat signal. The major challenge with RF signals is finding a way to similarly segment the length of each heartbeat for the purpose of emotion analysis.
So what we have to do is to also estimate the template of what this heartbeat signal looks like and how to segment it over time. So the idea is that there is some repetitive signals going on. Now we developed an algorithm that can detect this repeated pattern and segment each instances of them. And we come up with the optimization algorithm that trying to maximize the similarity between different segments. That's how we get the interbit interval.
Now that Katabi and Zhao had developed the basis of EQ radio, the next step was to find subjects for testing.
So I want to mention that Mika is one of our volunteers, and very early volunteers. We tested the breathing signal and the heartbeats, our ability to extract breathing and heartbeats on her.
Once it was determined that EQ radio could accurately pick up on Mika's physiological signals, they recruited human participants to test emotion recognition.
So what we did is that we first need to recruit people that can elicit certain types of emotions. And from previous studies shown that people with acting experience are actually pretty good at this. So they can control the emotion and can basically, for example, if you want them to cry, to be sad, they can make it happen. So the best way for someone to make himself happy is him to prepare some stimuli before the experiment.
So is a sensorless EQ radio system as accurate as an ECG?
So it comes with comparable accuracy, but you really don't need to put all of the sensors on someone, and even that act on its own can change their emotions.
EQ radio's ability to predict if a person was feeling joy, anger, sadness, or pleasure had an accuracy of up to 87%. With such promising results from the study, what could the future of EQ radio look like?
I would imagine like in the future, you would have your home understanding your emotion and start playing music that fits your mood. And as I said, even more importantly, understanding when there are real mental health issues, like somebody really falling into depression and being able to react and improve their health. I think this is a bigger vision. When exactly would be there, I can't tell you, but I hope that we can be there in the near future.
Learn more in the September 2018 Communications of the ACM in the Research Highlights article, Emotion Recognition Using Wireless Signals.